Hello there, exercise 10C.1. We're going to look at differentiation using a rule called the quotient rule. We saw the product rule last time, more or less, and this now then is the quotient rule. Basically is the opposite of the product. The quotient rule is about dividing. So if you ever get a one function divided by another and you're asked to differentiate it, then this is the rule that allows you to do it. Now this is written in a slightly odd way, this graphic, but you'll see why it looks like that in a bit. So this is the way I would expect you to be, what I expect you to be looking out for. Look out for functions basically with a division in, or e to the 3x divided by 2x plus 1, or I've got this divided by this. You get the idea that whenever you get a divide, we're going to call these two things u and v, and we basically separate them in two different functions. It's always u and v. So this one's going to be u, this one's going to be v. And as long as you do that, you can then use the rule. And this is the rule. Now this line's moved, I don't know why, there's the line. So if y equals u divided by v, then dy by dx is this. It's v du by dx minus u dv by dx all over v squared. We'll put it a different way. Sometimes we write it with dashes instead because it's quicker. So rather than writing du by dx, like we have here, we just write u dash, and you should have seen this notation before to mean when it's being differentiated. So notice y dash or dy by dx is v u dash minus u v dash all over v squared. Importantly, I always try to remember this. It is given to you in the formula book. You'll notice the v starts the whole thing off from both top and bottom. So just bear that in mind. Here's a question. It says use the quotient rule to find dy by dx. Okay, so my u is going to be the top thing, always the top thing, and my v will be the bottom thing. And I'm going to use this notation. I think it's just quicker, so I'm going to write u dash. If I differentiate that, I get 3, and if I differentiate the v, I think I get 2x. So bearing all that in mind, I'm going to write, or I'm personally going to write dy by dx equals, now this is when you get a bit of timesing going on, you get v times by u dash. Now v is there, u dash is there. So x squared plus 1 times by the 3. Now we better put that in a bracket or else we'll go wrong. Minus, nearly went wrong there, that was nearly a good start. Now minus these two times by each other. So it says u 1 plus 3x times by this v dash 2x. And it's all over v squared. Now very often you don't bother multiplying this out. So very often you'll just write x squared plus 1 squared. And there's temptation to want to multiply that out, but very often you don't bother. See, it'll be interesting to see what we do here in a bit. Anyway, I'm going to multiply the top out. Definitely need to do that. 3x squared plus 3. And if I multiply out this, I get minus a 2x minus a 6x squared all over that bracket squared, which was x squared plus 1 squared. And what's this give me? Finishing off, I think I get a minus 3x squared, a minus 2x plus a 3 all divided by that bracket squared. Now look, that is not very nice. I agree with you there. It's not very nice, but that's the answer. 3, well they put the 3 at the front. Other than that, it's exactly the same. And notice they didn't multiply out the bracket. So a second answer then, or second question then, is here. And it says, okay, we've got still got a quotient. It says find dy by dx, and we're just going to chuck it in. So I'll write u equal to the top and v equal to the bottom. Now I personally write them in that order, one above the other, simply because they're written in that order anyway. So then you can quite quickly write u dash next to it, that's 3. V dash, hopefully you remember what you do with an e to the 2x becomes 2e to the 2x. The power doesn't change. So dy by dx is equal to, remember it's v u dash, so it's that. And if I do that, I best write it in a nice order, 3e to the 2x minus, and now I times these together, and I reckon that's 2 3s are 6 x e to the 2x and it's all divided by the bottom squared, which is e to the 2x squared. Now actually I think I can do a bit of work on this, because I think e to the 2x comes out as a common factor on the top. I particularly like that because I think it will sort out the bottom. But when I do that I get 3 minus 6x divided by e to the 2x squared. I just think that will cancel with that, and I'm going to end up with 3 minus 6x over e to the 2x. Quite nice, straightforward, aren't they? Look at that, they've even factorised the top one step further. They've taken that out, but that's right, and that's right as well. They're both right. Next one, we've got a trigonometric function now. So set u equal to the x, and just write these out. Everyone will expect you to write them out, so put them down. And now I should remember that sine cos minus sine minus cos. So if I differentiate that sine, it's going to get cos. So anyway, u dash equals, well, differentiate x, I get 1. V dash equals cos x. So put those into my equation, dy by dx equals, so remember it's vu dash minus uv dash. That times that, well that's easy, that's sine x. When I times sine x by 1 I get sine x, I'm just going to write that. And this becomes, notice it's uv dash, which is x cos x. And that's divided by v squared, which is sine squared x. Again, temptation is to write it like that. It might be possible just to tidy it up a bit. I'm not sure what the answer does, but you could write this, because it's over one thing, it's basically both bits have got to be divided by the sine squared. So I can do sine x divided by sine squared minus x cos x divided by sine squared. And the only thing I'd say is I'm not convinced that really makes it any better. You could argue that this gives you 1 over sine, which is sec x, cosec x, sorry. This would give you this would give you x tan x sec x. It's like, no, I can't see that that is better. So I'm going to stop there. I'm going to see if that's the answer. And yeah, it is. That's all the answers done as well. And as I say, you don't know when to stop sometimes, but it didn't seem to be getting any better when I went down that route, so that's why I didn't bother. I think this is the last example, for now at least. So y equals cos x over 4, so write u equals cos x. And v therefore is x to the 4. U dash, now again, just write sine cos minus cos. And you'll notice cos becomes minus sine. So I shall write minus sine x. And x to the 4, v dash, therefore is 4x cubed when I differentiate it. So anyway, dy by dx, what do I get? Start with the v and go to the u dash, so it's x to the 4. I'm going to put the minus at the front from that sine x. Minus x to the 4 sine x minus 4x cubed cos x. All divided by x to the 4 squared. Now I can tidy that up quite easily, so I probably will. The top I don't like so much. I think I'm going to take out minus x cubed as a common factor. Not very nice, but I will. I'll get x sine x plus, because I've already got the minus here, so that's a plus as well, plus 4 cos x. Not very pretty, over x to the 8. I can't really see that that gets any better. Oh, of course, yes, it does. The one last step for me. Look, these cancel. I did it, but then didn't do it. So this cancels with 3 of these, and it gives me minus x sine x minus the 4 cos x. I've kind of got rid of that bracket now. Divided by, and now there's only x to the 5 on the bottom. And now I've got the same, and they've put minus, but you don't really need the bracket on the top. So I am happy now with that. That's a definitely better answer. And that's it. So it's a bit of practice. I've suggested questions 1 and 7. Have a go at those, and we'll see what we do. If we get more done in class, then brilliant. We're certainly going to look at this again in the second lesson. So, take your time, make sure you get them right. Thank you.